Let's continue our discussion on ensembling learning and random forests. Specifically, we're going to discuss boosting, and we're going to discuss AdaBoosting methodology. Here is a review of ensembling itself, the difference between bagging versus boosting. Remember, bagging is really just run different samples, and boosting is trying to build upon weak learners' weakness, try to correct that weakness from one step to the next, so that with the hope that at the end it will be a decent model. So this is a bagging illustration, again, multiple samples and multiple decision trees, and then combine the results from all the different trees. And then what is boosting? Boosting is also called hypothesis boosting. It refers to any ensemble method that can combine several weak learners into a strong learner. That's the idea of boosting. So let's look at this one. So we have the original data set, and then you have red circles and green circles. We are hoping to come back with a decision boundary like what we saw here. And then what we're trying to do is, for different iterations, we only building some very simple model. That simple model is called something called stump. It's just one decision, one root node with two leaf nodes type of simple decision tree model. As you can see here as an illustration, it's just one stump. In other words, we want just come back with one cut. So randomly, let's say that first iteration, we come back with this line, and then correspondingly come back with this decision tree. And then you can see here, if we have this line here, what happens is we have some sort of misclassification, right? All these green dots, these three, are misclassified to red on this side, right? And then for this side, these three red and these four reds are misclassified. So this first model is not doing well again on these three green nodes and these three red nodes and these four red nodes. So next iteration, what we do is for the ones that we misclassified, we can increase the weight to those nodes. Apparently, you can see that increase those nodes, the size of the node, which essentially tells you that we're increasing the weight of those nodes. So that next time when we do this new classification one more time, we may be coming back with this line. And then again, we know some of them would be misclassified. In this case, most likely, we will come back with this, okay, these are the reds, this would be the green, for example, then a lot of them might be misclassified, right? Just continue with this, continue all the different iterations, a bunch of stumps, and then we put all of them together to come back with a decent model. That's called boosting. We're going to have specific examples to tell you how this can be done. Let's look at AdaBoost. So AdaBoost sequential training with instance weight update. The same kind of idea. Suppose that we have the original data set look like this. We want to, for the first iteration, we build a model and come back with this type of prediction. Oh, this model is doing reasonably well on majority of the nodes, but it's not doing well for this node, right? And then what we do is we increase the weight of this node to start for the next iteration. And then once you do, okay, this node weight has been increased so that if you build a new model on this, it's likely to come back with this because it's going to fit reasonably well for this node. Now, for the second model, apparently it's not doing well for those nodes. So I have to increase the weight of those nodes. And then you continue to build a new model, that new model trying to fit those nodes really well. Again, some other nodes, these two are not doing well, and then you increase the weight and continue. So you just continue with this. Of course, it will stop somewhere, and at the end, you try to understand all this model together to come back with a decent model. That's called AdaBoost. On the moon data, you can see that for the different learning rate, we're going to discuss what learning rate is so that you know how these two are different. But conceptually, again, you should be aware that you start with model 1, and then you kind of improve to model 2, model 3, model 4, model 5, and it's just by adjusting learning rate, you kind of get a different picture of the AdaBoost performance on the moon data. We're going to discuss this learning rate shortly so that you know what that is. So let's understand the algorithm. So initially, each instance or observation's weight, Wi, specifically for that ith observation, is said to be 1 over m. If you have m observations, 1 over m, equally distributed for each individual observation's weight. And then for the GIS predictor is essentially one model. And then that can be defined, weighted error rate can be defined as yj for this JS predictor for the ith observation is the JS predictor's prediction for the ith instance. If that prediction is the same as if it's not the same as the actual value, then you sum that weight together. So if you have a misclassification, then it should appear in the numerator. And in the denominator would be all the weight, summation of all the weight. Okay, and then we use this error rate to update predictor weight. Predictor essentially a new model, a new predictor or new classifier. It's called a predictor. So the more accurate the predictor is, the higher its weight will be. So if it's just guessing randomly, then its weight will be close to 0. So we use error rate to update predictor weight. And then predictor rate can be updated by this equation. Each one of them 1 minus rj divided by rj, and then logarithm times this eta. Eta itself is called learning rate. So alpha j is the predictor weight. So now we have learning rate, we have predictor weight, we also have weighted error rate. So the AdaBoost updates the instance weight, which boosts the weights of the misclassified instances. As I just mentioned earlier, you have a mechanism to add the weights to the misclassified instances. So if you happen to be your prediction is okay, then you use the weight. Otherwise, you use weight times exponential of alpha j, so that you could increase the weight for those misclassified samples. So it's one way to boost the weights for next iteration. That comes the reason that we call it as AdaBoost, right? We boost the weights of the misclassified instances. If you recall, right here, we're trying to boost this one here because it's a regression, more like a regression model, but here we're boosting the weights of these misclassified nodes. The question is, what methodology you can boost that weights? Here you go, you have the AdaBoost. The number step 4, what you do is all the instances weights are normalized. After you do this, you normalize the weight, essentially divided by summation of Wi, and the new predictor is trained using the updated weights. A new predictor is a new model, and the whole process is repeated. The new predictor weight is computed, the instance weights are updated, then another predictor is trained, and so on. So once you do that, continue with all the steps, then the algorithm stops when the designed number of predictors is reached, or when a perfect predictor is found. So if you have predefined 100 predictors, then you stop there, or when a perfect predictor is found. So that's AdaBoost. You boost the weights of misclassified samples. To make predictions, AdaBoost simply computes the predictions of all the predictors and weighs them using the predictor weights alpha j. So the predicted class is the one that receives the majority of the weighted votes. So you use the predictor weights that we defined in step 2, alpha j, to predict your final prediction. So it's used where n is a number of predictors, and then what you do is from first predictor all the way to n, and then use the predictor weights alpha j, summation of that, given that if your for that j's predictor, your y estimate equal to k, particular k class, and then you find that maximum, you highlight that as your corresponding prediction. That's AdaBoost prediction. And then let's look at the implementation in scikit-learn. So in scikit-learn, it uses multi-class version of AdaBoost called SAMME, which stands for Stage-Wise Additive Modeling Using Multi-Class Exponential Loss Function, SAMME. So you import ensemble, import AdaBoost classifier from sklearn.ensemble, and then you can define this ada_clf equal to AdaBoost classifier. In here, you have decision tree classifier, and put the decision tree classifier there with max steps equal to 1, and with 200 decision trees. Of course, we also call it stumps, right? And the algorithm is SAMME.R, which would be AdaBoost. Learning rate is that Ada that we discussed in step 2 equal to 0.5, and then you fit from X and Y to fit this model. So a decision stump is a decision tree with max steps equal to 1. In other words, a tree composed of a single decision node plus 2 leaf nodes. That's AdaBoost implementation in scikit-learn. And that's pretty much everything that we want to discuss with AdaBoost. Thank you.